Hello everyone, in this video I'm going to show you how we can configure the HSRP or Hot Standby Routing Protocol, which is one of the first hub redundancy protocols that we use to add redundancy to our network. So first thing first, I'm going to show you the topology for this network. Actually, this topology shows our network without configuring the HSRP, or when we don't have redundancy in the network. As you can see, we have one call center in Winnipeg with 2 buildings. In each building we have a router and we have 2 access switches which are connected to our head office located in Ottawa, and then we have the HCP server and one separate network and the connection to the ISP. So as you can see in this network, there is no redundancy. So it means if in this call center in one of the routers in the for example west side building or the east side building goes down, connection from the clients of that building to the ISP will be lost and we don't have redundancy. And what we are going to do, we are going to add redundancy to this network by using the HSRP, and then our new design will look like this. This is the post HSRP configuration or topology. As you can see, we have now a trunk link between these 2 switches. We have the HSRP configured on these 2 routers. So whenever we have a connection lost in one of the buildings, for example on the west side or on the east side, still the clients on that building will have connectivity to the ISP because we have redundancy. So one of the routers will function as an active router and the other one will be a standby. So suppose if on the west side the connection goes down, clients in the west side can still reach the ISP by using the router in the east side, and vice versa. If on the east side the router goes down, client on the east side will be able to use the router on the west side and reach the ISP. So I have built this topology, and first of all I want to show you how the network works without using the HSRP. So I have configured this network with these 2 IP addresses on west side and the east side as the default gateway of the clients in each building. So on the west side is 172.17.1.253, and on the east on the east side is 172.17.1.254. And I have put actually a static IP address on PCA. I'm just to demonstrate, I only use PCA and PCC. They are in the same VLAN. We don't have different separate VLANs. We only have one VLAN here. And to demonstrate the connectivity from these PCs to the ISP, which is here, is our loopback 1 on Ottawa office. I'm just gonna turn them on. The static IP address has been set with the default gateway of 172.17.1.253, and on this side with 254. So I'm just gonna turn on my equipment, and I will show you that whenever one of these routers goes down, we will lose the connectivity, and then we will configure the HSRP and do the verification. So because this network is already configured, I'm not using the DHCP for now because I have the static IP address configured. So, and loopback 1 on Ottawa with this IP address represents the ISP connectivity, and there is a default actually route that goes to the ISP from Ottawa, that goes to loopback 1. So I'm just going to connect to my client PCA, check the IP configuration, and let's see if we can ping the the ISP. Also, I'm gonna connect to PCC because it's using a different, it is in the east side and it is using a different default gateway. Okay, so this is PCA, as you can see, PCA, which is on the west side. So let's check the configuration. As you can see, this is actually a static IP address. It's not getting from the DHCP. The DHCP is off now. 172.17.1.4 with this default gateway. So let me see if we can ping the default gateway first. I can ping the default gateway and I will ping the ISP, which is 111. I can ping it. Okay, so that was PCA. Now let's go to PCC. I will do the same. Config. I will ping 172.17.1.254, which is the default gateway. As you can see, it is 254. And I will ping the ISP 1111 and I can ping it. So now if, for example, on the west side, if this link or this link goes down, or even if this router is shut down or for some reason it reboots, I will lose connectivity to the ISP. Let's test this. If I just -T, now I put the continuous ping, I'm connecting to the ISP. Let me go to the router and shut down the link. So I'm gonna also connect to my routers on the west and the east side. Okay. I'll go to the west side router. This is the west side router. conf-t. Let's go to the serial 10, which is going to the ISP. For some reason, the serial link goes down, shut down, and you can see as soon as I shut down this interface, I lose the connectivity because there is no other way and we don't have redundancy. The same will happen on the other side. So we no shut the port, and yeah, so I can see that I have the connection. The same thing will happen here. So if for some reason this link goes down, I will lose connectivity to the ISP. So what I need to do, I have to configure the HSRP, and when we configure the HSRP, these two routers will use a virtual IP address instead of using their own IP address as a default gateway. This is the virtual IP will be used as a default gateway of our clients in both buildings, and then after they actually go to this default gateway, then depending on which router is the active router, the packets will be forwarded to the ISP. I will do the configuration and then we will check the verifications. So I have to set up a link, a trunk link between these two routers, these two switches, access switches, because packets, if there is some issues with this router, it goes down, the packets should be able to go to the other router. Okay, so I'm just gonna stop this. And there are no special configurations on these switches. They are just the access switches because we don't have any VLANs configured. So I'm just gonna connect these two switches on gig 02. Okay, and then I turn them on. Okay, now both switches are on, and if I go to the PCA, yeah, I can see that I have shortly I should have connectivity because this switch went down. So as soon as the ports are up, we should have connectivity because nothing changed. Or maybe let me see if the port is shut down or not on the west side. Show IP interface brief. So serial 10, no, the port is up, I think. Serial 10 and 253. So let me connect to switch 1. Yes, switch 1 is up. Show IP int brief. Okay, all my interfaces are up. Let me see if I can. Yeah, I can now ping. Okay, so right now I have connectivity. I just connected these two switches. Now I'm gonna go and I will configure the HSRP on these two routers. First, let's start with the west side. So I have to configure the HSRP on this interface. So right now, if I check Ethernet 00, so it has just one IP address. Also, because I want these PCs to get the IP from the DHCP, which is configured to give IP addresses in this range to the PCs with the default gateway of 172.17.1, I have to also configure IP helper address. So I go conf t, it's Ethernet 00, IP helper address 172 dot, and my DHCP server is 31.1.100. Let me just first show you the, also I'm gonna turn on my DHCP server. And also if I go to my Ottawa router, I will show you the IP address. So as you can see, my Ethernet 01, which is going to the DHCP server, is 11, and the DHCP server is 172.31.1.100. So this is my DHCP server. I'm gonna just show you the DHCP configuration. But right now, those two PCs are set as a static route, as a static IP address. So at this point, no DHCP IP will be distributed to the clients. Clients are using the static now. Okay, I'll just wait for the server manager to run. Okay, so I'm gonna go to the DHCP service, which is already configured. So as you can see, my scope, my address pool is from 172.17.1.2 to 1.100. At this point, there are no IP leases, and a scope option, the default gateway is the virtual IP address of the HSRP. So after my clients get the IP, I will see the address leases from here. Okay, let's go back to my configuration. So, and of course, I just wanted to show you something else, that the IP address of our DHCP, because we need it to give it to the IP helper address, is 31.1.100. So if I go, this PC is 31.1.100. This is 1.1.100 IP helper address. We need to put on the west side. Okay, now to start configuring the HSRP, so I put a standby one. Is the group number, the IP, and the IP of the virtual IP address is 11. Then I use a standby version 2 or the HSRP version 2. And also I enable the preemption. So it means if this router is, for example, the active, and then it goes down, the other router becomes active, and after it is up, it will resume the active role. So standby 1 preempt. And also I want to track two interfaces, like this interface and this interface. If one of these interfaces goes down, then what it happens, this router will be no longer will be active. Okay, so it means the track object will decrement the priority of this router, so it no longer will be active, because the traffic should go to the active one. It will go to the standby. So what I will do, because I want to track both interfaces, of course the syntaxes sometimes, depending on the iOS version of your router, is different. For example, in this version I cannot say standby 1 track. I can sometimes use the after track 1. I can use the interface line protocol. I just say track 1 and standby 1 track 2. Then here I have to go and define my track objects, what to do. So track 1 interface serial 10 line protocol, and track 2 interface Ethernet 00 line protocol. So it means I am tracking the line protocol of these two interfaces. If they go down, by default it will decrement the priority of this router. So show run int Ethernet 00, and this is my configuration of the standby router. On this side, I write my configuration, then I go to the east side. I have to do the same thing. Show run int Ethernet 00 on the east side. I only have the IP address, so int Ethernet 00 IP helper address 172.31.1.100. standby 1 172.17.1.1 standby 172. There is the issue. Why it's giving me the error? So show run int Ethernet 00. So IP helper address is okay. So conft int Ethernet 00 standby 1 IP 172.17.1.1 standby version 2 standby 1 preemption and standby 1 track 1 and track 2. Now I have to define track 1 interface serial. Here is 1 line protocol. I exit and track 2 interface Ethernet 00 line protocol. So show run int Ethernet 00. This is my configuration for the, so it will decrement 10. So what I'm gonna do also, I want to make this west side the active router. So how I do that, I go to Ethernet 00 and I put the standby 1. I put the priority, because the default priority is 100, I put 105 and it will be the active router. So in case any track object goes down, it will decrement 10, which will be 95, which is lower than the default priority, and it will be the standby. So now if I issue the command show standby, I can see that this one is the active router and the priority is 105. The other one should be standby. Show standby to check the HSRP configuration, like status. You issue this command. It is a standby and the priority 100 default. Now let's check. If I go to this system, okay, right now what I want also to do, I want to put the IP as a DHCP, and I should see if my system gets the IP from the DHCP server. So the gateway, I don't want to put 253 because right now we have redundancy and my default gateway will be my HSRP virtual IP address. So I go here, go to the IPv4, and you can see I have a static IP. I just put it on the DHCP. So, and I will check. So shortly I should be able to get the IP from the DHCP server. Right now I didn't get. So shortly I should be able to get the IP. Still not. Okay, let me go to my DHCP server. So this is my DHCP server. Actually, also I can check from here. Whenever I get the IP, it should show it here. Let me check again. Okay, still I didn't get the IP address. So ipconfig / release and renew. Let's see. Let's also check show run int ethernet 00. Let's check if the IP helper address is 31.1.100. Also, let's check if from this PC I can reach 172.31.1.100. I cannot reach this, so that is the issue. Now let's go to, okay, let's go. Oh, this switch was off. So this switch, access switch between my router and the switch was off. That was why. So now if I go to my switch, I should be able to reach it shortly because the switch was off. Now I go back to my PCA. I'll just shut down. I should be able to get the IP shortly. Ping 172.31.1.100. It takes some time for the switch to boot up. Still not. Okay, let's show IP interface from the head office. Let's see if I can check ping 172.31.1.100. Okay, yeah, so now I can ping from the head office. I can ping from the west side. I can ping the DHCP server. Let's go to my DHCP client. Let's disable this one. Enable. Okay, I think I got the IP now. So as you can see now, I got the IP address 172.17.1.2. If I go to my DHCP server also and just refresh, and as you can see, this is my PCA which got the IP. The same thing should happen with PCC. So right now I have the IP address on PCA. Let's close everything. Just we want to then verify. So as you can see now, the IP address is 12 and the gateway changed from 253 because on the DHCP server we specified the virtual IP address or this IP address as the default gateway. Now this PCA has this one as the default gateway. Let's go to PCC and I have to do the same. I have to put the IP as the DHCP because right now it is static IP address. Okay, I go here. Okay, this is a static, so I put it on the DHCP. Okay, and I have to check now 13. It got the IP from the DHCP server, and the gateway, as you can see, is 11. Okay, now what I will do, config, and okay, now I'm gonna just do the verification. So what actually I will do, from each PC I will ping the gateway, and then we will check the routers and the connectivity. So from PC A I ping 1111-T. So I'm pinging the ISP, and I see, you can see that I can ping. Also from this PC, PCC, ping 1111-T. Okay, so from both PCs you can see that I can ping the now what I will do, I will shut down one of these interfaces. For example, S10. Suppose the west side connection to the ISP goes down. So I'll go here, the west side. I want to shut down this interface. So I go conf t int, say I'm on the west side router. Serial 10, and I shut it down. So let's see what happens. So now I lost the connection. And the connection should come back up because we have the HSRP. So it is timeout, and now you can see that again, now I have connectivity. Although this interface went down, but still I have connectivity from PCA. What happened here? If I go show standby, now you can see that west side is going to the standby mode, and this one, which was standby, now is active on the, so the packets now are going from this router. To verify, what I can do, trace RT 1111, and it should go from here. So as you can see, now it is going from here. Actually the default gateway is 11, but it shows when I trace, it shows the IP address of the physical interface. Okay, now if I say conf t int serial 10 no shut, I no shut the interface, and now if I trace 1111, now you can see that it changed to 253. It is now going from this router, which is the active router now. So show standby, and you can see it is the active, and it's going from here. The same thing will happen if this router goes down or one of the interfaces goes down. So let's check PCC, and PCC, let's see where is the traffic going. Trace RT 1111, so it is going from the active router. Actually the packets, it goes from here because now this one is the active router. So even if I now turn off or shut down this router, still I will have connectivity because it is using the active. or when it goes down, it will be active here. So if I go to east side and I put the continuous ping, now I can ping, and now this time on this router I shut down the interface E00. So you see that I have continuous ping, so nothing happens. Or if this interface goes down, the active router, let's see, int ethernet 00 shut down. I will only lose a couple of packets, and then so timeout, and now again I have connectivity. So it means now this one is the active router, and if I trace trace 1111, it should use the default gateway as 254, as you can see, because now this one is the gateway. So we verify the connectivity. Whenever one of the routers in one location goes down, we will still have a connectivity, as opposed to the time that we didn't have the redundancy. So if one of these router goes down, we will lose the connectivity from the clients on that side. But with the HSRP, we have one router as active, one standby. So if one location goes down, we will still have connectivity. I hope you enjoyed this video. Thank you very much.